Starting Google Colab. So yesterday I have shared the recorded sessions of the pandas and part one and part two of the pandas notes. Both the things I have shared with you. If anybody missed that Saturday session, please do the practice. Go through the recorded sessions. Just wait, connecting with the runtime. Yeah, today, main agenda of this session. File handling with pandas. That means reading data from file. That means the first step. Reading data from file. The file has header as first line. Just check the data. I open one plain text file. So this is the file. Totally here, first line is header. Comma is the separator. ID, name, salary, gender, and department. Totally 5 columns. Second line onwards data here. So I keep this in the notes. Let's say input file emp.txt. Data is like this. So before practicing, first create a file with this data, with this name, and then start working. First, I will upload this file into Google Colab. emp.txt. So file is uploaded here. So for us, the current path is just check the current path in the Google Colab. PWD means the current working directory, which is the Linux command. So current working directory under root content is the folder. Under content folder, you have emp.txt file. So read underscore CSV. This is a step function to read data from file. I mean delimited file. Observe the statement. First, I am importing the pandas. Port pandas as PD. df equal to pd dot read underscore CSV and give the path of it. Under content, emp.txt. Now check the data of the df. So totally index number starting from row indexing is starting from 0. 0 to 6 means there are 7. Look at the first line. In our file, first line is header. That's why the header became columns. Okay. Suppose the second case, just before the second case, just check the data types. df.info. So totally 5 columns are here. ID is taken as integer. Name taken as object means string here. Salary integer. Gender string. Department number, integer. Similarly, one more file. Reading data from file. File does not have header. So this is the case. Just check for another file. emp1.txt. Look at here, there are 13 rows with comma separator between the fields. But in the first line, there is no header. First line onwards, everything is data here. I copy this data. Input file emp1.txt. Data is like this. No header in file. This is the case. First, I will upload this into Google Colab. emp1.txt. Uploaded. Now let's read this data. df equal to pd dot read underscore cs and giving the path content emp1.txt. But we don't have header. That's why you have to specify the option header equal to. We need to assign our columns. Names equal. This is option to assign the column names. In the form of list, you are giving column headers. So before this statement, I will prepare the columns. Column should be as a list. The first column, ID. Second column, name. Third column, which is salary. The fourth, gender. The next, department number. These are the columns. So in the place of names equal to list, I give columns. Now look at df. Totally index number, last index is 12 means there are 13 rows. So based on this description, the list of the column list, here column headers have been applied. Okay. Now I want to perform different transformations. So for this data, let's apply a tax. 10% of the tax I want to apply to the data frame. df of tax equal to. So what is our rule? During assignment, if given column not available, it will create a new column. For this input, salary. So for the salary, 10% tax I am applying. That's why point. Similarly, HRA. df of HRA equal to df of salary into 0.2, 20% I am applying. The net salary, df of net salary equal to df of salary plus df of HRA minus the df of tax. Now additionally 3 columns will be created. Already 5 columns you have. Now 3 new columns will be created. Total 8 columns you will see here. Just check the data. Observe here first The last three columns. Last three columns are about tax, HRA, net salary. Okay. So now conditional transformations how to perform. That means I want to replace the values. Task one in gender column. Replace M as male, F as female. So to do such kind of things, we have three ways. Number one, replace function. Number two, map. Number three, apply. In this way, three different ways to perform these conditional transformations. So this is task one we do with the replace. Okay, another task we do with the map, another task with we do with the apply. Let's observe with replace I am going to do. For the replace, input should be dictionary. Observe here I am going to target the gender column. DF of gender. Input is gender only. DF of gender. Dot replace. Further replace input argument should be dictionary. So here format like this, old value, colon, new value. On that way, any number of pairs you can. So here my old value is M. If it is M, I want male. Similarly, the old value is F. If it is F, I want to replace with this female. Look at this output now. So previously gender values M, F like that. Now male, female, full gender names. Got it? This is one way. Now same kind of operation we do with map. For the map also input should be dictionary. If key not available, it returns null. This is additional functionality when compared with the replace. If key not available, it returns null. Observe the statement here. I am targeting a department number column. The task 2 is like this. Transform department number to department name. I have the values 11. 11 I want to make it as marketing. Similarly 12. Department number 12 is here. This 12 I want to make this as HR. 13. 13 I want to make this as finance. Remaining, that is other than 11, 12, 13. I want to make them as other. Now same task with replace you can do, but to replace if the value 11, 12, 13 other than these three, if any remaining thing is there, it cannot return null value. But map returns. In the dictionary, if I keep 11, 12, 13, if any 14 record is passed, for the 14 it returns null. Observe the same thing. I'm targeting the department name now. Input is a department number. Applying map function. Your input should be dictionary. So before this statement, I prepare one dictionary. The dictionary is DEPT, department. 11 is key. Marketing is value. Similarly, department number 12 is key. Value HR. One more 13. 13 is finance. In the place of dictionary, I am keeping this dictionary DEPD. Suppose for the 13 it returns finance, for 12 it returns HR, for 11 it returns marketing. Suppose 14, 15, 14, 15 not available in the dictionary. So this function returns null. If it is null, I want to replace that null value, fill NA. Here NA means not available. Not available means null value, fill NA. If it is null value, I want to replace this with other. Okay. Now look into this DF. One more new column is created here. The new column name is D name, department name. Now check the things. Look at last column. Department 11 turned as marketing, 12 HR, 13 finance. And what about 14, 15? 14, 15 not available in the dictionary. That's why I got other. Okay. Now thing is perfect. Okay. Now I'm going to do with apply. Using apply function, you can apply custom functions, custom Python functions on data frame. Suppose I build my own logic in my custom Python function. So how to apply that to your Python function on the data frame is by using apply. So format is like this. Apply of data frame and your column name. Dot apply of your Python function. That's it. This is the form. Okay. So again, I build the data from scratch onwards. I do different, all these different conditional transformations. Once again, I am reading the data from the scratch. pd dot read underscore CSV and giving the path of it. Content emp1.txt. We don't have header. Header equals to no. 1 minute. And one more header no. Column name 7. Column names directly in the form of list I am giving. First column ID, second column name, third one salary, next one gender, last one department. Once again, look at the data. Now your data is in original state. Now I want to perform different conditional transformations using apply. First I am targeting department number, that is gender. Create a function to transform gender into full gender names. I am creating a function in Python. How to create a function using a def keyword. Def to Z. I am passing gender value. Let's say G for gender. One default value I am fixing here as in value. If G equals to M, then gender is male. But in the given data, there might be some small letters, there might be some uppercase letter. That's why what I'm doing is, whatever the value passed, first I'm converting into lower. Then I am comparing with G. Or else in the beginning only you can do this operation. G equal to G dot. If G equal to M, I want to return male. Else if G equal to F, then gender female. If these two conditions false, I already fixed one default value, which is invalid. Finally, I am going to return this. Return child. Now, just to test this function first, to gender. Capital M I am passing. Actually, in our data, there is no capital letter M. I got male. To gender, some small letter F I am passing. Female, I got it. Suppose in the given data, there is other than MF characters like X. This is returning invalid. So that function is working fine. Now I want to apply this on our data frame. Df of gender equal to input column same df dot gender dot apply. What is the previous function? To gender. That's it. We give only the function name. That's it. This is to gender is here, your Python custom function. Okay. Now check the values of the data frame. Look at gender column. Perfectly transformed. Okay. Now same style. Target this department. So create a function to transform department numbers into department names. Define to data. Department number I am passing. Department number equal to other, some default value I have fixed. If DNO equal to 11, the DNAME marketing. Else if department number equal to 12, then DNAME HR. Else if department number equal to 13, then DNAME finance. If these three conditions are false, we are returning that default value other. Return other. Not other. Department name. Now test this first. 2D name of 11. What is expected? Marketing. 2D name of 12. Expected value HR. 2D name of 13. Expected finance. I am passing something different, which is 20. Other is expected. So function is working fine. Now I want to apply this on the data frame. Df of dname equal df of department number is input dot apply. What is the function name? To delay. That's it. Now look at the values of the DF. Look at last call. Department name is produced. Similarly, one more function will make it. Create a function to generate salary grades. Suppose salary greater than or equals to 1 lakh. Then grade A. If salary greater than or equals to 75,000 and salary less than 1 lakh, then grade B. If salary greater than or equal to 50,000 and salary less than 75K, then it is grades. If salary less than 50K, then grade D. So this is the task. For this task, the equivalent Python function will prepare first. Define to grade. Input is salary. First default value I am fixing. Grade D. Now targeting grade A, which is salary greater than or equals to 1 lakh. If salary greater than or equals to 1 lakh, then grade equals to A. Else if salary greater than or equals to 75,000. So no need to check less than 1 lakh because first condition false means value is definitely less than 1 lakh. Then grade equal to B. Still else if salary greater than or equals to 50, then grade equals to C. Already default value D we fixed. If all the three conditions false, then grade is D. Now we are returning. Return grade. First independently check it. 2 grade of 1 lakh 20. A grade. 2 grade of 80,000, which is between 75 to 1 lakh. So that B is expected. B grade. 2 grade of, let's say, 30. 30 is less than 50. So that a D grade. Correct. 2 grade of 60, which is 50 to 75. So that B is C grade. Correct. Okay, now let's apply this on the data frame. DF of grade equal to input is salary dot apply. Our function 2. Now look at DF. One more column is created, that is grade. The last few rows are A grade only. First one 90 means B grade, 20 means D grade, 60 C grade, correct. All the grades are right. So again, the old new columns, tax HRA also I am creating here because I want to show you how to write all the transformer data into output file. DF of tax, DF of salary into 0.1. DF of HRA is DF of salary into point. That's salary. salary plus HRA minus tax. But data is not in my required order. I want to arrange this data into my required order. DF of first I need ID. Next name. Next salary. Next tax I want. After that HRA. After that net salary. After that grade I want. Then gender. Then department number. Then department name. So I arranged the data in my required format, required order. Now it is purely clean. I want to write this to output file. To write data into output file 2 underscore CSV. And here I am giving the file path content. Let's say new emp.txt. But whenever you are writing, it writes these index numbers also. I don't want those index numbers. That's why index equal to false. Now check this. Check the output file. New emp is created. So this is the data. Just I keep in plain text. Other here, ID input is having only 5 fields, but now we generated 10 fields. We read the data. After that, we perform different transformations. Finally, the results we have written into new. So I keep this output also into your data. One more last operation. I want to write into Excel file. Then df 2 underscore Excel. Content. New emp dot Excel SX. I think Excel SX. Okay. I don't want index numbers. Index equal to false. Now test this. I think the file will be downloaded. Excel S6. Check the downloaded file. That is downloaded into this downloads. This is newmp.xlsx. So now that are data perfectly written into Excel. Okay. Similarly, how you are applying a 2 underscore CSV in the same style to read data from an Excel file, 2 underscore, sorry, read underscore Excel. Okay. So still one more session I will take on the pandas, one more last session. In that file, we work with multiple files and we apply the unions and joins on that file. Okay. After that, we perform some data cleaning activities. All the things we will see. That thing I will demonstrate on the next class tomorrow. Okay. So I will share this recorded session by the afternoon. So, thank you.
Sir, I have one question.
We use immediately. I need to rush up into another session.
Okay, okay. No
just
problem.
ping me in the WhatsApp.
No problem. Thank you, sir.
Hmm?